Alrighty, welcome to the next part of calculus. Really, calculus is all about three big ideas: limits, which we've done; derivatives, which you just finished; and integration, which is essentially derivatives, but it's the same thing but backwards. There's more applications that we can do with antiderivatives and integration, but we'll get into that as we go. But integration is another super powerful part of calculus. So what is integration? We have two types of integration: indefinite and definite integration. Indefinite, all that means is that I'm going to find my antiderivative or integrate just in terms of variable. Definite means I'm actually going to be able to find like a value to give this thing. So first off, what is a derivative? Not a derivative, an integration. So let's see, to kind of walk you through how this goes and what I think through in my head, to find a function whose derivative is this is integration. So it's the same thing but backwards. So instead of thinking in terms of taking the derivative, you're going to think about undoing the derivative essentially. We would call this function, or we could call it, big F of x equals x cubed, because the derivative of x cubed is 3x squared. So the antiderivative, a lot of the times it is represented as this large F. There's not any big rhyme or reason that I know of as to why we call it big F, other than that's what I'm just used to seeing in text. We will also need to add a constant c unless I'm given a specific solution to where my function should be hitting, because the derivative of a constant is 0. So this could have been like 3x squared plus 7, and it would be a parabola that has been moved up 7. It could be 3x squared minus 12 or whatever, right? So I don't know what that constant is that the derivative could have been 0. So we would see this as f of x is x cubed plus c. You could also see this asked as the integral of 3x squared dx. This first part is the integrand. The inside is what you are taking the antiderivative of, and the dx is the terms of integration. So just like we had dy dx, dx kind of tells us what variable I am integrating with. Okay, so that's pretty much it. We're just going to work through these things and see what we can come up with. There's some basic rules that you guys can kind of follow, but I don't really think about the rules too much. I just try to take what the derivative of what function would give me this. So if I'm looking at 8x cubed minus 9x squared plus 4, well, this would be equal to in order to get 8x cubed, I could have had 2x to the 4th, right? If I take the derivative of that, then that's 8x cubed, minus 9x squared, so 3x to the 3rd, plus 4x plus some constant c. That is my solution. Kind of, sort of, I'm not being able to think about the best terms to put this in. But if I'm adding 1 to the exponent here, I'm going to divide by my new exponent. If I add 1 to the exponent, I divide 1 to by the new exponent. And I add 1 to the exponent, so I could divide that by 1 if I wanted to, and then plus c. That's kind of like the power rule for these things. Okay, so looking at the next one, I would rewrite these as a power rule before I even do the integration. So the integrate of x to the 1/2 plus 1/2 x to the negative 1/2 dx, which would be x to the 3/2, so 2/3, and then this would just be plus the square root of x. And then I have plus c. Right, so again, take your time, go backwards with this. That's your check. That's really what you should be thinking about as you're doing these things. It's kind of how, what derivative do I take in order to get what I see inside? So take your time. Make sure you're checking your work. You really have to be checking your work in order to do these properly. This one I would rewrite as 3x to the negative 7 dx. which would be, let's see, we add 1 to negative 6, so 1/2 and negative plus c. Yep, so if I take the derivative, I will have 3x to the negative 7th. So let's see, derivative of 0 would just be a constant, right? It's just some number. Sorry, derivative, the integral of 0. Stop saying derivative. Likewise, the integral of just dx, that's essentially the integral of 1, would just be x, and then get in plus c. You got to remember that plus c. They'll give you a point sometimes on the AP test for just getting that plus c. Okay, sine plus cosine. So this must have been negative cosine plus sine plus c. Right? In order to take the derivative of that, the derivative of negative cosine will give me the sine, and the derivative of sine will give me the cosine. Again, that's really all that I'm thinking about, is just going backwards with this stuff. The next one is pretty ugly, but I would just rewrite this. So I would have the integrand of x over root x minus 12 over root x dx, and I would rewrite that as x to the 1/2 minus 12x to the negative 1/2 dx. So this would be 2/3 x to the 3/2. And then let's see, we'd have to do 1/2, so 6x to the 1/2 plus c. All right, so let's think about how the derivative works out. Yup. And the derivative of 6x to the 1/2, that is not right. That should have been 24, huh? Right, so if I take 1/2 of 24, then that is 12. Adding 1 to my exponent. Yep, should be good there. All right, so really take your time. Go through what is the derivative of this, what is the derivative of that. Do they map into my integrand properly? If they do, then I'm cool. If they don't, then I need to think about it. All right. Find the general solution to the differential equation. We could get into the separation of variables here, which isn't a bad idea. But really, just remember that dy dx, right? This would just be like y equals 5x plus c. Separation of variables, what I mean by that is right now I have dy and dx kind of on the same side. What I can do is if I multiply that dx up, then this becomes dy equals 5 dx. And now, if I'm trying to find the general solution, I'm trying to find the equation that it could have come from. So if I take the integrand of both sides, the integrand of y would just be y plus c, and the integrand of 5 would be 5x plus c. Since these are just constants, I don't know which constant either of them are, so I can combine them and just make them into a big constant, which will give me to y equals 5x plus c. Because it could have been like 3 and 4, could have been negative 12 and 5. I don't know what the constant is, but they don't subtract to make 0. Okay, well they could. I guess they could, but we don't know. All right, so with this next one, I'll do the separation of variables again, just to get you some good practice on it. I would rewrite this as 2x and negative 3 dx. And then if I take the integrand of both sides, then this is y plus c is, let's see, that would be x to the negative 2. So in order to get 2, I would have negative 1 plus c. All right, let's think about that. Bring your negative 2 down. It will be 2. You subtract 1 from the exponent. So I would have negative x to the negative 2 plus c. That would be my general solution. Again, these are general solutions because I don't know where this constant c is. It could be 5x plus 7. Could be 5x minus 2. So you'll see things that are called slope fields, which are whereabouts your function would be, which we'll get to these later too. Right, so those solutions right there, those are called slope fields. Right, so my slope, it mimics this logarithm function as I go out, and for my particular solution is what it's called, where it hits a certain point, it will follow this slope field. If this were moved down or if it were reflected over here, it would have followed one of these slope fields. So the slope field is something that we'll get into much later, but it's kind of the general solutions for these functions as they go, depending on what point that they have to go through. Okay. Probably more than you wanted to know at this point. Find the particular solution that satisfies the differential equation on the initial condition. So this is a point where we are given the initial condition. So I'm given a point that I have to go through. What this is going to allow me to do is find that value of c such that the derivative is the derivative of this exact function. So go ahead and take your antiderivative. So f of x would be x squared plus c. Now if it has to go through 119, that means that if I put in 19 for y and 1 for x, then that c is something that I can solve for. So that means c is 18. So f of x is equal to x squared plus 18. That would be my particular solution. Okay. All right. So f double prime, and this time I'm given f prime and I'm given f of 0. So f prime of x would have been x to the third over 3 plus c. Since I have to be able to put in 0 for x and come out with 8, f prime of 0, which is 8, so 8 equals 0 over 3 plus c, so c must be 8, which means that f prime was x cubed over 3 plus 8. Then I'm still trying to go into my particular solution, so I want to go to f, which would mean I would add 1 to my exponent and divide by that new exponent, so plus 8x plus c. And then I will use the fact that f of 0 equals 4 to help me solve. Well, that's nice because if x is 0, that's 0, that's 0, so that means 4 equals c. So instead of that c, I will say my particular solution is x to the 4th over 12 plus 8x plus 4. Alrighty. All right, last one. So let's see, f prime would be negative cosine of x plus c. And if I put in 0, let's see what we got. 1 equals negative cosine of 0 plus c. 1 equals negative 1 plus c, so c must be 2. So that tells me then that f prime of x would be negative cosine plus 2. So f of x would be negative sine of x plus 2x plus c. Now if I put in 0, it's supposed to be 6. So 6 equals negative sine of 0 plus 2 times 0 plus c. Sine of 0 is 0, 2 times 0 is 0, so c is 6. So my particular solution to this one would be negative sine of x plus 2x plus 6. All right, this is just an introduction. Pretty quick little thing for you guys, but that's really all you need to know as far as kind of the starts to integration. Biggest thing is you are trying to find what derivative you took in order to get what we are integrating in terms of. I think you got a decent amount of practice for this. So as you're going through, as always, let me know what questions you guys have, and I will talk to y'all soon. Bye.